Okay, so let's talk about some of the basics. Let's talk about variables and operators in Java, and we'll be using Java REPL. For this, I actually have some other small YouTube video from before, but a lot of times when we are programming, right, we want to get some input into the process, we do some process, and we write some outputs, right? That's mainly what we do in programming. Many times we want to keep values in the middle while we are processing. And so that gives us the idea of a variable. A variable is just a name location in memory. Variables in Java have a name, a type, and a value. The name is something that we give it. The type, we also define it in Java. We give it at the beginning, and that's the type of things it will be able to contain. So if we declare it integer, it will only be able to contain integers. If we declare it a letter or a car, it will be only a car, one letter. If we declare it a double, then it will be a floating point number, a number with decimals, but that's it. It cannot contain other kinds of things. We can change the value of a variable. So if we declare a variable integer and we call it a, we can put different values in there, but we will never be able to change its type. I will show you Java REPL. We can do int a, and that declares an integer variable of type a. When I type a, it will tell me, oops, sometimes it gets confused. Maybe I need to initialize it. This is Java REPL only. Real Java will understand that. So now if I type a, it has the value of 0. This was because I never actually assigned a value to it. I can do a equals 10. This is horrible in terms of mathematics. We are using the same symbol, but in here it means put the value 10 into the variable a. It doesn't matter what it is, now it's 10. So we do a, we get 10. We could do a equals 20, and now a is 20. Java has, for ints, the standard numerical operator, so we can do 3 plus 4. That will give us 7. 3. For multiplication, we use the asterisk because x is actually a letter. So 3 times 4. We can do integer division. 3 divided by 4, if you go back to elementary school, that is 0 with a remainder of 3. So 3% 4 would give us the remainder. So we could do 3% 2, and that would give us 1, 3% 1, and that actually gives us 0, right? And then we could do also things like 3 divided by 2, and we can do minus 2, 3 minus 1. And 3 minus 1. In real Java, all your statements need to end in a semicolon. In Java REPL, they don't. So we have integer variables, right? This statement, int a, semicolon, would declare a variable a of type int. The semicolon means this ends this statement. That's it. So now let's go to the next. In Java, we always have to declare a variable before we can use it, and we have to give it its type. As we mentioned, we can assign a value with the assignment operator. So we can do stuff like a equals 10. We can, on the right hand side of the assignment, put whatever we want, right? So a equals 3 plus 4. We can do a equals 3 times 5. We can even do dumb things like a equals a times 5. And so a was 15, now it will be 75, right? Because 15 times 5 is 75. We could also have different variables. In b equals 3. And then we could do a plus b, or b equals a minus b, and other kinds of things. Notice that, again, right, this equal is assignment. Calculate this, and then stick that value into B. It doesn't matter what it was before. We can, as kind of syntactic sugar, declare and initialize in the same statement, and this is good because that means you don't ever forget to initialize. We can also use other kinds. We can declare several variables in the same line. So this line would declare 3 variables of type int. One of them is x and its value is 10. The other one is y, and we didn't initialize it. And the other one is z, and its value is going to be x plus 1, which is 10 plus 1, which is 11. Java REPL doesn't support this syntax, but real Java does. What can we use to name our variables? First of all, important thing, we should name them with something that denotes their meaning. For these kinds of examples, I tend to use a or x, which is not the best thing to do, but you can use letters, you can use numbers or digits, you can use the $sign and an underscore. You cannot start a variable with a digit. Lowercase and uppercase letters are different. So we can actually declare int $sign a equals 1. And that's the name of my variable. Or int underscore a equals 1, and that's perfectly okay. What I cannot do is do int 1a equals 1, because it will look at this 1 and think that I'm trying to write the number 1. And so that's important to know. There is a strong convention in Java to start our variables with a lowercase letter and use capitalization to break our word. So if we want to do gear ratio as our variable, we'll write gear on lowercase, capital R because we are starting a new word, and keep going. If we are doing number of sides, we'll write number, the capital O for off, capital S for sides, and keep going. The first one is always lowercase for variables. We have all of the standard operators. The usual order, PEMDAS, works. There's no exponents, and parentheses also work, right? To save you some typing, instead of typing something like a equals a plus 5, you can write a plus equal 5. It is just syntactic sugar. So if we have a, let me actually make a equals 10. I could do a equals a plus 5, and that will make a 15, right? I could make it 10 again, and then instead of typing it like this, I can write it a plus equal 5. And that's the exact same thing as this a equals a plus 5. This and this have the exact same meaning, they just slightly different way of writing it. And actually we can write a plus plus for increment a with 1. So a would not be 16. There is a small difference between a plus plus and plus plus a. This one returns the old value of a, this one returns the new value of a. So if we were gonna do a is now 17, if we were to do a plus 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 a, right? This would evaluate to 17 and would make a be 18. Now this would evaluate, this second plus plus a would evaluate to 19. So we'll do 18 plus 19, which is 37 maybe? Ooh, 36. Oh yeah, sorry. It's 17. This one is 17. And this one is 19. So it's 36. We'll do those exercises eventually. Floating point numbers. These are ints and we do integer division. We can also do double, which is the best way to declare floating points. You can also do floats. Let's do dA equals 1.2. and that works. I cannot do a equals 1.2. Java will normally complain. In this case, Java REPL doesn't complain, but real Java would do. And since they are floats, now I can do the right stuff. 1.2 divided by 2 is going to give me 0.6. It actually doesn't necessarily represent 0.6. We may have a problem but it represents a value very close to this. So it may actually be representing 0.5555, 59999, or something like that. It will still be printed like this, but sometimes when we do operations, we end up with weird things. In particular, you should never use equal to compare floats. And we'll talk about them again. So you can do ints, you can do floats. The concept of a variable is the same. Once I have the variable, I can put other things in there.